Integration by parts is really cool because it allows us to undo the product rule, and that's what you see right here. So sometimes you can undo the product rule if it's a power function in a pretty straightforward manner. Sometimes it's a little bit more involved, and it really comes down to keeping track of the pieces. No, I don't know why mathematicians group together letters for variables that are really similar. So u and v are just grouped together. So are x and y. Yes, they look similar, but guess what? That's just how it is. So this right here is the product rule. If you wanted to undo it, let's just do it quick and dirty way, you would integrate both sides. So if you integrate the left-hand side, you'd be back to uv, and you're looking at the integral of u prime v plus uv prime. So you can split apart the right-hand side into two integrals. So you have uv equals the integral of u prime v plus the integral of uv prime. And then you see this happen. So you know that uv minus the integral of uv prime is equal to the integral of u prime v. You're going to see versions of this many, many times coming up. What this summarizes to is this. The integration by parts, integration by parts. The whole key is going to be coming up with pieces u and v. You're going to have to pick u and v. You're going to have to pick u and v so that you can follow this path, so that you can follow this path. So that's the integral of uv prime dx is equal to uv minus the integral of u prime v dx, where u and v are both in terms of x. So it's u of x and v of x. And again, I apologize for it being u and v together. Key elements for choosing u and v. Whatever you let v prime be, you need to be able to find v. So you're picking something that you can easily integrate for v prime. So if you go back and look at this, you're picking something for v prime, you're picking something here that you can easily integrate. It helps if the derivative of u is simpler than u, and it helps if v is simpler than v prime. So what it really comes down to is being able to choose wisely. So let's work on this definite integral. You have to split this apart into u and v prime such that we can actually run integration by parts. So let's just split it here, here and here. Remember, dx there's an invisible 1 next to it. So let's call this part u, and let's call the next part v prime. I would like to see you making this grid. So you say u is going to be equal to ln x, and v is going to be equal to, and what u prime is going to be equal to, and what v prime is going to be equal to. So if we said v prime is 1 dx, there's an invisible 1, we know that v is going to be x. And we know that u prime, what's the derivative of ln? It's going to be 1 over x dx. So what does that mean we have? It means we have the integral from 2 to 3 of u v prime dx. We're saying that's going to be equal to, based on our rule, u times v from 2 to 3. We're doing a definite integral just to get numbers at the end, minus the integral from 2 to 3 of u prime v. So what are those pieces? Let's glue them together. We end up with ln x times x from 2 to 3, and then the integral from 2 to 3 of just dx. Now, why is it just dx? Well, if we actually substitute in right here, we end up with 1 over x times x dx. That's u prime times v. And then what cancels? The x is cancels, leaving you with just 1 dx. So you continue, and effectively what you're doing is x ln x minus, what's the integral of just dx? X from 2 to 3. So you end up with 3 ln 3 minus 3, plugging in 3, minus 2 ln 2 minus 2. Can you clean that up a little bit? Sure, but that would be fine for now. That would be fine for now. So once again, though, it's all about choosing u and v prime. So the first lesson here is that you want to have something that's easy to integrate for v prime. It doesn't really get much easier than that. And then you want something that generally makes a smaller, a nicer derivative. I know that's subjective, but the derivative of ln is 1 over x, and that is kind of nice. So let's do another one and see what happens. We're just adding on a little bit of layers here, a few layers here. So let's let ln x be our u. which would mean that the rest here would need to be our v prime. So if we write out that grid like I want you to write out, you know that u is equal to ln x, and we know that v prime is equal to x to the 6th dx, x to the 6th dx. Remember, it's chosen because we want something that's easy to integrate. So therefore, v is equal to 1/7 x to the 7th, and u prime is equal to, oh, again, 1 over x dx. This is an indefinite integral, so we're not plugging in any endpoints here, any limits of integration. So what do we have? What do you remember the definition to be? Well, maybe you've got it, but in case you don't, there it is again. So in this case, what are we going to end up with? We're going to end up with 1/7 x to the 7th ln x. That's our u times v. That's this part. And we're subtracting the integral of u prime v. So what is u prime? Oh, it's going to be 1 over x dx times, oh, v is 1/7 x cubed, or x to the 7th, excuse me. So if you do out some algebra, it jumps to something that's pretty easy to integrate. And what do you end up with? You end up with 1/7 x to the 7th ln x minus, well, 1/7, and then what does this integrate to? 1/7 x to the 7th. And then you have, oh wait, plus c. And yeah, you could factor out a 1/7 to make it a little nicer, but it's fine in that case. Just remember that constant at the end. So we learned you have to choose wisely and that you really need to be careful with your algebra. So here's this one. Name of the game here is be really careful with your algebra. Keep in mind here, we've also been choosing u prime and v values, so u and v prime values that have worked really nicely. That's not always going to be the case, but for now, let's keep that up. So let's say we chose u to be x squared. If we did that, it dictates that v prime has to be sine of 4x dx. Again, that was chosen because we wanted v prime to be something that's easy to integrate. So therefore, v is going to be negative 1/4 cosine 4x, yay. And u prime, hey, it does something nice, it's 2x dx. Okay, that's nice, but what does that build into? Well, we know, again, through our definition, we follow our definition here, we end up with negative 1/4 x squared cosine 4x minus this integral of 2x dx, the u prime, times negative 1/4 cosine 4x. It's not that bad, but it kind of looks cyclical. So let's see what happens here. Well, you do some algebra and it almost looks like you're back to the same thing. But we have some smaller powers, so at least that's helpful for us. The key lesson is here. Guess what we're going to do inside our integration by parts? We're going to do it again. We're going to do it again because this is still a problem. We don't know what the integral of that is off the top of our heads. Now I'm going to commit some bad form here and use u and v again. But in this case, u is just going to be x. And if u is x, v prime is going to be cosine of 4x dx. So when we do the integral, you end up with 1/4 sine of 4x. And u prime this time is just dx. That's kind of cool. So now we're just going to be working on this part inside the yellow. So what do we end up with? It's going to be u v prime. So it's going to be, uv. So we end up with x times 1/4 sine of 4x. And what are we going to subtract from that? Well, we're going to subtract from it, as the definition shows right here, u prime v dx. u prime v dx. So that's just going to be dx times 1/4 sine of 4x. Okay, so what's the point here? Well, when we do this, we now can actually just find the derivative straight off. So what do we have here? We end up with 1/4 x sine of 4x, just reorganizing the first term. And writing this a little nicely, it's minus 1/4, I'm going to pull that out to the outside, of, what is it? It is 1/4 sine of 4x dx. And you know that that's going to come out this. You have to be really careful here. You know that this integral right here is right there. So we've done everything that's in that box right there. So if we put this all together, you end up with that long string because, again, you have this 1/2 floating on the outside. So that 1/2 was multiplied there. And then you still have this piece, which came down right there. So the algebra can be substantial, and you sometimes have to do integration by parts inside integration by parts. I'm going to show you one more trick. Just because something's simple to write doesn't mean it's simple to solve, as you are well aware. So if u is cosine theta in this case, then, oh wait, v prime is just going to be cosine theta d theta. Okay, so we're cruising along here. We like these nice clean trig functions. So u prime is going to be negative sine of theta. Okay, that's great. So now we do u times v, so we end up with cosine theta times sine theta. Yay, okay, that's fine. And then we subtract negative sine of theta times d theta, sorry, times sine of theta. Okay, so there's actually a d theta right there. So just to recap, what are we looking at? This is u times v minus u prime v. Okay, this seems nice. Okay, let's just cruise along here. We don't have to do anything with that part, so we're okay with it staying like that. So we have plus the integral of sine squared theta. Well, yay, that's nice, but now we have to do effectively what we did before, but with sine. So let's see what happens here. If we do this one out, let's attack it the same exact way. Let's attack it the same exact way. So if we did that, we'd say u is equal to sine theta, v prime is equal to sine theta d theta. So v is going to be equal to negative cosine theta. And once again, u prime, not once again, but u prime this time is going to be equal to cosine theta d theta. Now, if you do out the algebra, guess what you end up back at? You end up back here. But then like, okay, this is what we figured out is the green part. So if we put this all together, we still have that part and we have all of this is our combined answer. We have cosine theta, sine theta, minus sine theta, cosine theta, plus, oh wait, this is nice, maybe something works. But what is this supposed to equal? It's supposed to equal this. These two terms cancel out, leaving us just with the true statement of the integral of cosine squared theta d theta is equal to the integral of cosine squared theta d theta. We've gone full circle perfectly. That is a true statement. So this is the trick I'm going to give you. Well, first a warning. One, you will do proper math and run into a wall like this, but then you're also at this point going to need to remember some basic trig. Let's do some basic trig. And the basic trig you're going to have to remember is that sine squared theta is equal to 1 minus cosine squared theta. Okay, so how does that help us? Well, let's attack this green thing again instead as the integral of 1 minus cosine squared theta d theta. And if we attack it this way, what happens? Well, that's really just two integrals. That's the integral of 1 d theta minus the integral of cosine squared d theta. Okay, so what does that, how does that help? I mean, it seems like we're in the same spot we were in before, almost, right? So we have, remember, this part is floating around out front right here. And now we have this right here. Well, let's integrate what we can. This just integrates to theta. So what do we now have? What do we now have? Let's bring all the pieces together. So our original integral was the integral of cosine squared theta. We now know that's equal to cosine theta from right here times sine theta. And what are we adding to it? We're adding to it theta, that's this theta right there, minus integral of cosine squared theta d theta. Okay, that's exciting. Fantastic. So what can we do at this point? Well, the whole thing comes down to the fact that this is still negative, so we can add it to the other side. So now we have, oh wait, we have two of these things, two of those. So what do we end up with right now? We end up with 2 of cosine squared theta, there's a d theta right there, d theta, and this is going to equal cosine theta sine theta plus theta. So divide by 1/2 and you end up with the integral of cosine squared theta d theta is equal to 1/2 cosine theta sine theta plus theta. So once again, the lesson here is, oh wait, we're done because we do have it written without an integral on the right-hand side. That's really nice. So sometimes, like, this is all correct right here. This whole section is correct, but we ended up with a true statement. That doesn't help us. Yes, 5 equals 5. The integral of cosine squared theta d theta is equal to the integral of cosine squared theta d theta. So what you do is you remember that you can bail at this point right here. You can bail at that point, and you need to remember your basic trig. So in this case, it was that sine squared theta is equal to 1 minus cosine squared. So to recap, we're undoing the product rule. When you make your choices, let v prime be something that you're able to integrate, and it helps if u prime is simpler than u and v is simpler than v prime. When you're doing a definite integral, the limits stick around from the beginning. Sometimes things aren't written in a nice order, so you have to pull them apart. Sometimes the algebra isn't super fun, sorry. And sometimes you have to use parts inside parts, and remember your basic trig. Have fun and see you soon.